Good morning friends, I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. Let me discuss about Epsilon NFA in this video. Before going for explaining about the Epsilon NFA, we have already discussed that we have a finite automata. The finite automata can be classified into two types. One is that finite automata with output, then finite automata without output. Is it clear? And the finite automata with output, we have Mealy emission and Moore emissions. Till now we have not discussed what is a Mealy emission and what is a Moore emission. However, finite automata without output can be classified into three types: DFA, NFA, and then Epsilon NFA. Now in our previous videos we have discussed what is a DFA and how can I represent a DFA, and we have discussed enough examples for constructing a DFA. Is it clear? Then we have moved to the NFA. We have discussed what is an NFA and what is the difference between DFA and NFA, how to represent an NFA, and we have discussed few examples for constructing an NFA. And then we have discussed converting an NFA to a DFA procedure with few examples. Now we will discuss about the third variant, which is Epsilon NFA. We will discuss what is an Epsilon NFA, how can I represent an Epsilon NFA, and how can I convert from an Epsilon NFA to DFA or NFA. Meaning is that Epsilon NFA to NFA we will discuss. Already you know that procedure for converting an NFA to DFA. Is it clear? So we will discuss after that converting an Epsilon NFA to an NFA. Now if you see that the power of, remember this point, the power of DFA, NFA, Epsilon NFA is same. The power or the capability of these three mathematical models are same. Meaning is that for any given language, if you can construct an Epsilon NFA, you can construct an NFA and also a DFA. But for any language, if you cannot construct Epsilon NFA, is it clear? Then we cannot convert into an NFA and we cannot convert into a DFA. Or I can say that if we cannot construct an Epsilon NFA, then we cannot construct NFA and also DFA. Because for any language, if you can construct an Epsilon NFA, I can convert into NFA. Then for that language, NFA is there. And from NFA, I can convert into DFA. Then for the same language, we have a DFA also. Is it clear? So I can say that the power or the capability of all these three models are same. You please note down this point. This is very important question especially for interviews and also for the any competitive exams like GATE, UGC NET, etc. Okay. So I want to start about the Epsilon NFA. What is an Epsilon NFA and how to represent the Epsilon NFA we will discuss now. Now if you see that from NFA or DFA from any state, let's take that I have alphabets A comma B. If I want to move from one state to another state, either I need to take the help of the alphabet A or I need to take the help of the alphabet B. Meaning is that from any state, it can be initial state or any state, from any state to if you want to go to another state, you need the help of the alphabets. Either you have to move on the alphabet A or you have to move on the alphabet B or on both. Is it clear? But in Epsilon NFA, from one state to another state, you can move on epsilon moves. Is it clear? You can move on in epsilon. So these kind of moves we'll call it as an epsilon. This is the extra advantage of Epsilon NFA. Now what is the NFA? From any state, on taking any alphabet, you can go to more than one state or you don't need to go to any state. That property is still valid for Epsilon NFA. Means what are the properties are there for NFA is still there. The extra advantage for Epsilon NFA is you have epsilon moves. So it have all the properties of NFA with extra property called epsilon moves. That's what we'll call it as an Epsilon NFA. So now let me represent Epsilon NFA. So we have represented the NFA, DFA using the 5 attributes. So now we will discuss. We have a Q, we have a sigma, we have delta, we have Q naught, and we have F. What is the Q? Set of states. Set of states in the epsilon NFA. Sigma is the alphabets. Here please remember the alphabets, if you have A comma B, you will have epsilon also extra. Is it clear? Till now you have alphabets A comma B. Here if you have alphabets A comma B, always extra alphabet will be there, epsilon. If it is 0, 1 also, you will have extra alphabet called epsilon. And Q naught is your initial state. Only one initial state is possible. Okay, only one initial state is possible. And F is set of final state. All these things we have already discussed. The same valid for NFA, DFA also, and even for the epsilon NFA. But only difference is that you can have alphabet called epsilon also. Now this transition function for a DFA is Q naught on sigma, you will go to Q. This is the DFA. For NFA, Q on sigma, you will go to 2 power Q. Okay, this is NFA. Now coming to the epsilon NFA, Q on epsilon union alphabets. From a state Q on epsilon union alphabets, you will go to 2 power Q state. So this is the extra advantage of epsilon NFA. If you see that there is only difference between epsilon NFA and NFA is that on NFA, from a state Q on alphabets A or B, you can go to more than one state or you may not go. So this is what we call it as a power set. Whereas in epsilon NFA, from a state, by taking alphabets or epsilon, you can go to more than one state or you may not go to any state. So that is the only difference between the NFA and epsilon NFA. So I hope you have understood how can I represent the epsilon NFA.